Welcome to my presentation. This presentation is part of the playlist Integral of Logarithmic Functions. In this presentation, we will be solving example problems related to logarithmic functions. Let us look at some examples. We want to evaluate a function integral e to the power of minus x divided by 1 minus e to the power of minus x dx as shown here. So we're going to substitute u as equal to 1 minus e to the power of minus x, 1 minus e to the power of minus x, which is in the denominator. Since u is a function of x, we're going to differentiate this function with respect to x. So as you can see here, du by dx is equal to minus of minus e to the power of minus x. So d by dx of 1 is a 0. D by dx of minus e to the power of minus x is going to be equal to, the negative sign is that, and then d by dx of e to the power of minus x is minus e to the power of minus x. So like that. So therefore, when we simplify this, negative times negative is a positive. So therefore, du by dx is going to be equal to e to the power of minus x. So I can rewrite this as du as equal to e to the power of minus x dx. So I can, if I want to express this in terms of dx, I can write as dx is equal to 1 over e to the power of minus x du. Now we can substitute u as equal to 1 minus e to the power of minus x and then dx as equal to 1 over e to the power of minus x du into the given example problem and then use the rules of integration and solve it. So our given example problem is integral e to the power of minus x divided by 1 minus e to the power of minus x dx, right? So integral e to the power of minus x is the numerator. Wherever we see 1 minus e to the power of minus x, we're going to substitute that by u as stated here. And then wherever we see dx, we're going to write 1 over e to the power of minus x du as shown here. Now as we can see here, we have e to the power of minus x in the numerator, e to the power of minus x in the denominator. These terms cancel out. When we simplify that, we are left with integral 1 over u du. We know that the rule is stating that integral 1 over u du is equal to ln of u, like that, plus c, where c is a constant of integration. Now, we want to be able to express our solution in terms of x and not in terms of u. So therefore, wherever we see u, we will replace it by 1 minus e to the power of minus x. So therefore, this translates to ln of 1 minus e to the power of minus x plus c, where c is a constant of integration. This is the way we want to be able to solve example problems involving logarithmic functions. Let's look at another example. Okay, in this example, we want to be able to evaluate integral 2 over 1 plus e to the power of minus x dx as shown here. Now, before we start to solve this example problem, we want to simplify the problem a little bit more. So we're going to take the denominator 1 plus e to the power of minus x and then rewrite it as 1 plus 1 over e to the power of plus x. So when the negative exponent comes to the denominator, it becomes a positive exponent, like that. So I'm going to take a common denominator between 1 plus 1 over e to the power of x. E to the power of x is a common denominator. So the numerator becomes ex plus 1. So therefore, we can rewrite the given problem as integral 2 divided by e to the power of x plus 1 divided by e to the power of x dx. Since we have a term in the denominator, this comes to the numerator, and we can rewrite this as 2 e to the power of x divided by e to the power of x plus 1 dx. Now we're going to solve this example problem. We're going to let u be equal to e to the power of x plus 1, and that is what we have at the denominator. Okay, since u is a function of x, we're going to differentiate it with respect to x. When we differentiate that with respect to x, this is what we have. D by dx of e to the power of x is e to the power of x. So therefore, du by dx is equal to e to the power of x and we can rewrite this as du as equal to e to the power of x dx. So we brought the denominator dx to the side of the expression here. If we want to express this in terms of dx, we can write as dx is equal to 1 over e to the power of x du. Okay, now we can substitute u as equal to e to the power of x plus 1, and then dx as equal to 1 over e to the power of x du as shown here into the given example problem, and then use the rules of integration and then solve it. So now our simplified problem is as shown here, integral 2 e to the power of x divided by e to the power of x plus 1 dx. Okay, since 2 is a constant, so we can write it outside of the integration process as shown here. E to the power of x divided by, wherever we see e to the power of x plus 1, we're going to replace that by u as shown here. And then wherever we see dx, we're going to rewrite that as 1 over e to the power of x du. So now we have successfully substituted all the terms. Now, as you can see here, we have an e to the power of x term in the numerator, e to the power of x term in the denominator. Those terms cancel out, leaving us with 2 times 1 over u du. We know that integral 1 over u du is equal to ln of u, right? So therefore, we can rewrite this as 2 ln of u plus c. But we cannot leave our solution in terms of u. We need to express it in terms of x. But we started to say u is equal to e to the power of x plus 1. So wherever we see u, we're going to write ex plus 1 as shown here. So therefore, 2 times ln of e to the power of x plus 1 plus c, and that is where that is our solution, where c is a constant of integration. So this is the way we want to be able to solve example problems related to logarithmic functions. In my next video presentation, we will be solving more examples related to logarithmic functions.